Before we start our tutorial video today, if you love our videos, please click on like button and make sure to click on subscribe and bell icon to receive notifications of future helpful content of automation and process control. Now let's get started. From field to control room. Understanding Profinet, Profibus DP and PA. In today's video, we'll break down the differences between Profibus PA, Profibus DP, and Profinet. These three protocols are widely used in industrial automation, but each one serves a different purpose and operates at a different level of the automation hierarchy. The big picture. Before we look at each protocol individually, here's the overall concept. Profibus PA for field instruments in process industries. Profibus DP for controllers, PLCs, drives, and high-speed devices. Profinet for workstations, HMIs, engineering stations, and high-level networking. Each protocol has its own speed, topology, and required hardware. Profibus PA, process automation. What it's used for. Profibus PA is designed for field transmitters, valves, and smart instruments in process plants. Key characteristics: low communication speed, but extremely stable. Supports intrinsically safe zones, EX environments. Carries power plus communication on the same cable. Deal for long distances in harsh industrial areas. Required hardware: DP-PA link or segment coupler to connect PA to the main Profibus DP backbone. Shielded twisted pair cable. Use cases: oil and gas fields, refineries, chemical plants, water treatment, and any plant with hazardous areas. Profibus DP, decentralized peripherals. What it's used for. Profibus DP connects high-speed automation devices such as PLCs, motor drives, remote I/O, high-speed sensors and actuators. Key characteristics: much faster than PA, up to 12 megabits per second. Used mainly at the control layer. Not suitable for hazardous areas. Purely communication, does not power the devices. Required hardware: standard DP cable, purple. Profibus connectors. Repeaters for long distances. PLC with DP master interface. Use cases: factory automation, conveyor systems, packaging machines, high-speed control loops. Profinet. What it's used for. Profinet is the Ethernet-based successor to Profibus, used at higher network levels for operator stations, workstations, engineering stations, high-speed controllers, industrial PCs, safety and motion control. Key characteristics: very high speed, real-time and isochronous modes. Uses standard Ethernet cables and switches. Long cable distances, easy network expansion. Supports diagnostics, alarms, and large data volume. Required hardware: industrial Ethernet switches. Cat5e Cat6 shielded cables. PLC or IPC with Profinet interface. Use cases: SCADA systems, DCS networks, robotics, modern manufacturing, and high-level plant communication. Summary comparison. Profibus PA IEC 61158, Mbp, low speed, fixed 31.25 kbps, stable, intrinsically safe, mainly for field instruments, hazardous areas. Profibus DP IEC 61158, RS, 485, FDL, medium speed, 9.6 kilobits per second to 12 megabits per second, for PLCs, drives, remote I/O, deterministic master-slave communication, without relying on Ethernet protocols. Profinet high-speed, Ethernet-based, TCP/IP, UDP, RT, IRT, 100 megabits per second, for OS, SCADA, and network-level communication. In the end, this diagram brings everything together and shows how industrial communication truly works inside a modern process plant. Each layer in the architecture plays a specific role. Profinet connects the higher-level controllers and engineering stations, ensuring fast data flow across the entire plant. Profibus DP links the PLCs to the field equipment that requires high-speed and time-critical performance, such as drives, motors, and remote I/O modules. Profibus PA, on the other hand, provides a safe and reliable network for process instruments, pressure, temperature, and flow transmitters operating directly in the field. When we look at the complete picture, we can clearly see how these protocols complement each other rather than compete. Together, they form a structured and hierarchical communication system. Profinet at the plant level, Profibus DP at the field device level, and Profibus PA at the process instrument level. This layered setup ensures that every device, from the simplest transmitter to the highest level controller, can exchange data efficiently, safely, and in real time. This architecture is the backbone of modern automation. It allows process plants to achieve seamless integration, consistent diagnostics, optimized performance, and reliable operation. Understanding how these networks connect, from the field all the way up to the control room, is the key to mastering industrial communication. If you found this helpful, like, share, and subscribe for more instrumentation tutorials. Thank you so much for watching and have a nice day.